Hello everyone, and welcome back to David IB Course. Today we're diving into one of the most profound and beautiful ideas in all of modern mathematics. It's a concept that completely changed how we see the world around us, revealing a hidden, intricate order where we once saw only chaos. So, let me start with a question for you. What if chaos was never chaos at all? For centuries, when humans looked at nature, we saw something magnificent, yet utterly unpredictable. A jagged mountain range, the intricate branching of a tree, the swirling patterns of clouds, they all seemed beautiful, but fundamentally random. It felt like these shapes were beyond the reach of our neat, clean geometric formulas. We had squares and circles, but how do you mathematically describe a cloud? It seemed impossible. For the longest time, we accepted this apparent randomness as a basic fact of the universe. But then, a brilliant and unconventional mathematician came along who saw something that everyone else had missed. His name was Benoit Mandelbrot, a Polish-born French-American thinker who wasn't afraid to ask strange questions. He worked at IBM, where he had access to early computers, which allowed him to explore mathematical ideas visually in a way no one had before. He asked a question that seemed simple on the surface, but turned out to be incredibly deep. How long is the coastline of Britain? Think about it. If you measure it from a satellite image, you get one answer. But what if you use a smaller measuring stick, say 1 mile long, and walk it along the coast? You'd have to account for more of the smaller bays and inlets, and your total length would be longer. Now, what if you used a 1-foot ruler? The length would get even longer, as you'd now be measuring around individual rocks. What if you went down to the scale of a single grain of sand? Coastline's length would just keep growing and growing, seemingly towards infinity. Mandelbrot realized that the answer to his question changes depending on how closely you look. The coastline has a property called self-similarity. The little wiggles and jags look a lot like the bigger bays and peninsulas. This observation was the key that unlocked a whole new branch of geometry. Mandelbrot gave it a name: fractal geometry. A fractal is a shape that repeats its own pattern at every scale, no matter how much you zoom in or zoom out. And this led him to one of the most famous and complex objects in all of mathematics, the Mandelbrot set. When you plot this equation on a computer, you don't get a simple line or a curve. You get this incredibly intricate, bug-like shape. But the magic happens when you zoom in on its edges. As you get closer, you find tiny, microscopic copies of the entire Mandelbrot set, hidden within the patterns. And inside those copies are even smaller ones, repeating forever. It's a doorway into an infinite world of structure and detail, all generated from a very simple formula. This was the breakthrough. Suddenly, the seemingly random shapes of nature started to make sense. Those clouds that defied simple geometry. They're fractals. It's the branching of a lightning bolt, the structure of a fern, the jagged peaks of a mountain range, the veins in a leaf. Even the vast, sprawling structure of galaxies, all of these things are built from simple, repeating fractal patterns. What we had mistaken for chaos was actually an incredibly sophisticated and detailed form of order. Chaos wasn't disorder at all. It was a different kind of geometry in disguise, geometry of roughness, of complexity, of life itself. The discovery of fractals reveals a fundamental truth about our universe. It is far more structured, intricate, and interconnected than it appears on the surface. Hidden within the apparent messiness of the world is a simple, repeating rule that generates infinite beauty. It shows us that if you just know how to look, you can find perfect order in the heart of chaos. Thanks for watching. If you found this as fascinating as I do, make sure to like, subscribe, and hit the bell so you don't miss our next exploration into the amazing world of ideas. See you next video. Please click links in the description box below for more videos. Presented by David IB Course.